Hey, you're back. Hopefully you found the other ones helpful. I'm Mr. Hayes. Hayes' World of Math. I'm here to help you get ready for your AP Stats exam. Hopefully pass, get credit, hopefully get a 5. Who knows? Let me know. Before we get started, all of this stuff, everything for all 9 CED units is down below in a 3-week review course. I've got answer keys and all that other good stuff down there, links to all the different playlists for this. So please make sure you do that. And if you find these helpful, make sure you hit like. It helps me with the algorithm. Anyway, so over here we've got, this question is from CED 7. So we're going to be talking about inference of means. So it could be a confidence interval. It could be a significance test. It's all that fun stuff. And this one's from 2018. And they're talking about ACLs. If you follow sports, you probably know somebody who's torn an ACL. It helps stabilize the knee. This hospital has developed medical center has helped develop a new surgery, and they're trying to see, is this new procedure better than the traditional one? So they did 210 patients. And so here, based on the design of the study, oh, and by the way, 210 patients needing surgery to repair a torn ACL were randomly assigned to either receive the standard procedure or the new procedure. So based on the design of the study, would it be statistically significant? Would a statistically significant result allow the medical center to say, yes, this new one works? So how do you be able to say that there's causation, that one thing is affecting things? You need to have random assignment. You need to randomly assign it, and we do have that. So because the two surgery were randomly assigned, if a statistically significant result happened, the medical center could say it is because of the procedure. And what joy that would bring the medical center, right? Anyway, moving on. The summary statistics of the recovery time are down below. So the question now is, do the data provide convincing statistical evidence that this actually works? So now you're going to go through and do a full test. So right now we're going to do a 2-sample t-test for difference of means. Remember, it has to be, there's 2 samples because we have 2 different procedures. It's a t-test because we're measuring the number of days that the recovery time with the number of days. And so since it's not a proportion, proportions are z-tests, means are t-tests. Over here, we get the right marker. Over here, we give the statistical evidence. So it does say that the traditional standard surgery ended up, according to our numbers, took almost a full month more to do it. And then down over here, we're going to say the mu of s minus the mu of n is the true mean difference in the mean recovery time. Now notice we're doing the difference of means, and we're not doing the mean of differences because you're having 2 different groups, and you're not having one person doing both things. And that's more of what you do for the mean of differences. Alpha is 0.05. Null hypothesis, the mean of differences is 0. And the alternative hypothesis is that we want, and this is the part where sometimes get tricky. For this to be a success, the standard recovery time has to be greater than the new procedure recovery time. So we want this difference to be positive, which is why I put that there. Be careful when you're reading that. So again, you're going to have, you need to be very careful about how the wording is to know if it's less than, greater than, et cetera, and how it applies to yours. You could have also kept it as less than if I had switched the 2 around. So if you did mean of the new minus the mean of the standard, that would also be okay. So to check things out, we need to have random assignment. That's great. We don't have to worry about independence because we have random assignment. That takes care of it. And then last but not least, it is normal. Both samples are bigger than 30. So we can go from that. We don't have to look at the data itself. Now, for the calculated part out here, have the normal one down here. And again, this part right here is on your formula sheet. A lot of this is to make sure that you have redundancy and you're getting your head in the right place. So from there, we write down this massive formula, which is just a very big, oops, it's going to do something special. So we need to have that down there just because if let's say we forgot to name it, this would allow us to go through and get credit for that. We plug everything in. Please make sure that you square your standard errors down over there. And then over here, we get a t-value of 713. Now, when you look at this, now we have 99 degrees of freedom because we have 100 is the small. I'm taking the smaller of the 2 groups. That's always the safer. It's the more conservative way to do it. So we have degrees of freedom of at least 99. When you do that, it's going to be essentially 0. If you look at the chart, the chart is nowhere near 99. So because of that, we can just say essentially 0, and then assuming the null hypothesis is true, that there is no difference in recovery time, there's essentially a 0 probability of getting a t-value that is greater than or equal to 713 purely by chance. Since 0 is less than our alpha value of 0.05, we reject the null hypothesis. We have convincing evidence that the new ACL procedure does reduce recovery time when compared to the normal standard procedure. And that's it. We're done. That's all they have for this question. The biggest thing on these, remember, is don't get over anxious on this stuff. Take your time. Trust your gut. You did these for probably better part of 2 months. You'll be fine. And before we go, we've got some playlists over here for you. Again, like, comment, subscribe. We'll see you next time, and hopefully we'll get you to that 5. Catch you later.